SEN training program is happy to introduce the video for crew training. Please refer the follow video. In this video, we will explain how refrigeration system works and what each component's functions. Low-pressure refrigerant from the evaporator is sucked and compressed into high-pressure vapor by the compressor. This increases its temperature and pressure. After compression, the refrigerant passes through the oil separator, which removes any oil carried over from the compressor. The separated oil is returned to the compressor for lubrication. The high-pressure vapor enters the condenser where it releases heat to the seawater, condensing into a high-pressure liquid. The liquid refrigerant then flows through the dry filter, which removes moisture and impurities to protect the system from corrosion and blockages. Controlled by the thermostat, the solenoid valve regulates the flow of refrigerant into the evaporator. It opens or closes based on temperature, up or down. We can check the sight glass to visually inspect the refrigerant flow and detect any bubbles or moisture, indicating potential issues. The refrigerant then passes through the expansion valve, where its pressure drops significantly. This causes the refrigerant to cool rapidly and partially evaporate. The refrigerant vapors in the evaporator and become very cold. The cold refrigerant absorbs heat from the air. Fans circulate the air to ensure uniform cooling, while the defroster prevents ice buildup on the evaporator coils. Thermostat monitors the temperature inside the refrigerated rooms and sends the signals to the control system to open or close the solenoid valves. Before returning to the compressor, the refrigerant passes through the suction accumulator, which ensures that only vapor, not liquid, enters the compressor, protecting it from damage. Control panel: this central unit manages the entire system, displaying operational parameters, alarms, and allowing manual or automatic control of the refrigeration cycle. Pressure gauges: these gauges monitor the system's pressure at suction and discharge pipes. There is a low-pressure relay at suction pipe to stop the compressor when temperature is below the set point, and start the compressor when temperature is over the set point. There is a high-pressure relay at discharge pipe to stop the compressor when pressure is over the set point, to protect the compressor. There is a lube oil dual pressure relay, one side connected to discharge pipe, other side connected to lube oil pipe. This relay will stop compressor when pressure is under the set point to protect the compressor. Solenoid valve is closed by the thermostat when temperature of the refrigerating rooms is lower than set point. The system runs on the idle state. If the suction pressure dropping lower than set point, low pressure relay LPR stops the compressor to maintain the system at pause state when temperature of the refrigerating rooms is higher than set point. Solenoid valve will open and the suction pressure higher than set point. Low pressure relay will start the compressor. High pressure relay HPR stops the compressor for protection in case the refrigerant pressure is too high due to lack of cooling or there is contamination by air inside the system. Lube oil pressure relay LOPR to stop the compressor for protection in case the lube oil pressure drops down due to no lube oil. Coming back from lube oil separator or gear pump damage. During operation, water vapor tends to freeze on the evaporator coil, reducing heat exchange efficiency. The defroster operates in cycles to melt the ice buildup on the heat exchange surface and maintain optimal thermal performance. This is one of our videos in SEN training program for crew training. We do hope that you will be interested in our program. Thanks for watching.